Hi, this is Lakshmikant Tiwari, and in this lesson, I'm going to teach you about GloVe vectors and TensorFlow 2.0 and the Keras. The people have been requesting me to make a video on word to vector, GloVe vectors, and word embedding with the TensorFlow and the Keras. So, since last two videos, I have shown you word to vector representation of word and its classification, and in the previous video I have shown you how you can use TensorFlow 2.0 and the Keras to classify your text data. And since last two videos we have been working on Twitter data. As you know, previously we have been working with these Twitter data. Initially the Twitter data was 1.6 million it was having rows, but because we have very limited time during this live video session, so I had to reduce this data set to just 4,000 rows. In these 4,000 rows, 2,000 rows are with negative sentiment, and remaining 2,000 rows is with positive sentiment. So this is quite low in size, and we can use in this the video very easily. And then we will be using here GloVe vectors. You know, the GloVe vectors is global vectors. So there is very minor difference between the GloVe vectors and word to vector representation. You can understand that word to vector representation is kind of the CNN operation. I mean, the vectors of each word looks, they are nearby, I mean before and the after, how the words are coming, the occurrence of words before and the after of that particular word. But in GloVe vectors take like a global occurrence of that word with other words. All right, I mean in whole data set, or you can say in whole corpus. But in the word to vector representation, it sees the occurrence of that word with the before and after of that word. What is the frequency of that words with other words as well in the word to vector. So the global vector is kind of, it is co-occurrence matrix with the other vectors. Like you see how many times dog has occurred with the dog, of course it is always 1. And how many times dog has occurred with the police and dog has occurred with the T in a whole data set. All right, you need to understand this. In GloVe vector, we find that co-occurrence matrix of that particular word with other particular words, how it is occurring with other words. So it kind of makes a size of vocabulary matrix to find out those occurrence of the matrix, and then finally it project the occurrence of that words in a particular dimension. So the GloVe vectors is already available in a pre-trained format as a Stanford University website. There is a project GloVe, and that you can get here. So there are various kind of GloVe vectors are available here, especially those are available in 822 megabyte, and there is this one is available in 50 dimension, 100, 203 dimension. Since this is Twitter data, so we are going to use this vector. Okay, so Twitter, it has 2 billion tweets and 27 billion tokens, and its vocabulary size is 1.2 million total. Okay, so we'll be using this, and its size is 142 gigabyte, and you can download it by giving this link. So here is link, you can download it. It will download zip file, then you need to unzip it. Once you unzip it, you will get unzip folder like this, GloVe Twitter 27 billion. And once you open this, you will get these 4 different files, and these 4 different files will be having 200 dimensions vectors with the 100 dimension vectors and 50 dimensions and 25 dimensions vector. All right, perfect. Now without wasting time, let's go ahead and start this lesson. I have taken few lines from previous code, and those algorithms and videos are available on KGP Talkie website, KGP Talkie YouTube channel. in the KGP Talkie YouTube channel. So these are the two very important videos which I have covered previously. In these two videos you see here, we have TensorFlow 2.0 and Keras for word embedding on Twitter sentiment data, and here another one is complete text processing. So the text processing data I have taken from this video, and the Keras model and the TensorFlow model I have taken from this video. All right, perfect. Now let's go ahead and start this. So these are the few lines which we need initially, like we need a tokenizer, and we need paired sequencing, and we need sequentials, dense model, flat embedding activations, and dropout, as well as the convolution 1D, max pooling 1D, global max pooling, and optimizer Adam, and of course these are the other necessary libraries. I have covered these things previously in videos. If you are very new, you can go ahead and watch my previous video to understand these things in detail. So let's go ahead and run this. Once we run this, then we import the another library, train test split from scalar. Let's go ahead and import this, and now we are going to read this Twitter 4000 CSV file. Since this video is only to give an idea how you can work with the GloVe vectors and the Twitter data together, that is why I am taking just 4000 rows. Otherwise, if you are working on a large project, then you should take all the Twitter data together, although that might take a lot of the time to process. And here I am going to show you how you can do the pre-processing and the cleaning. And I should tell you that I have taken pre-processing and the cleaning in very detail in this 3-hour video, but I have extracted few lines of code from this video so that I can directly use those code without repeating the video. All right, so the first I'm going to do the contraction to the expansion. So these are the contracted words which will be expanded to like these words. Okay, like if I say the can't, it will expand it to cannot, and aren't will be expanded to are not, and so on. All right, so these are the contraction. And apart from that, I'll be also removing those words which have occurred only a single time in the Twitter data. The words which occur only a single time, it is because if you make a mistake in a spelling, then there is a high probability that that word will become only one time in whole tweet data. Otherwise, if you are just typing some random word, then that is also have a high probability that might occur just a single time in whole data set. All right, so I am going to get those rare word, and with this I'm going to get all those rare words just single occurrence. So all the word which have just only one time occurrence. And after that, you see here, I'm going to convert all the words in a lower format, and then here I am doing contraction to the expansion, and with this line of code I am removing the emails from the data, and from this line of code I am removing websites from the data, and from here I am removing the Twitter retweet. Okay, and with this I am just taking the numeric alpha data, okay, which have only the characters, not the numbers, and numerics data and other special characters are etc being removed from here. And then here I am only selecting those words which have occurred at least the 2 times. All right, and then finally I am processing this. So it get processed. It says that the contraction is not defined. I think, yeah, sorry, I need to run this line first and then this line. Okay, so it took just 464 milliseconds to process this. Now what we need to do, now we need to see the data, okay, which we have currently, like this tweet data. So here we have tweets. Now you see, now these tweets have been the cleaned. Now these are the very clean tweet. although we have other options too to clean it more, like spelling corrections and removing the stop words, etc., which I have shown in the previous video, and you can refer and you can do the more cleaning if you don't get a desired accuracy. All right, perfect. Let's go ahead and add few lines there. Now what we need to do, we need to see how many the sentiment values which we have here, which we can get with the value counts. You see we have ones 2000 time and zeros 2000 time. Perfect. All right, now let's go ahead and convert this data. I mean df tweet, this is actually a series. Okay, this is a series. Let's go ahead and convert this series in the form of list. So we are gonna convert this in the form of list. Now you see here the text, and let's go ahead and just see few lines of the text. So just 3 lines of the text we have here. So this series of tweets have been converted into list of tweets. All right, and here y, we have y in the sentiments. Now we have y and text. Now we need to tokenize this. As you have seen in the previous video, we have used tokenizer from Keras. So the same thing we are going to use here. Token is equal to df, and then we have sentiment. Sorry, the token is equal to tokenizer, and then we need to fit it, token dot fit on text, which we can do like this, and then finally I'm gonna pass here text. So the token has fit. Now we need to get the vocabulary size with vocab size is equal to length of token dot word index. All right, so with this word index we will get the full size of the token, vocabulary size of the token. There, let's say how much vocabulary size we have. We have total 6793 vocabulary. All right, perfect. Now let's go ahead and see the index. All right, so we can get this with the token dot index word. So with this we get all the words which have indexed in by this tokenizer. Like I has been indexed at the first place, 2 has been indexed at the second place, and so on. All right, this is how it is happening. So let's go ahead and now you see here we need to do sequence encoding as we did in the previous video. Why we need a sequence encoding? Let's say if I say x is equal to I u, okay, then in this you will see here, let me see it here, I have 1 and I'm not sure u, where is u? Let's say I and the 2 only. Okay, so let's say I and the 2 only. If I say I and 2, then a new token sequence will be made like this, 1 and 2. All right, so this is how it is gonna happen. Perfect. So let's go ahead and comment this, otherwise it will create unnecessary, it will take unnecessarily space. All right, so what we are going to do, we are going to encode this text. Once again, I'm telling you, if you are new, you can watch previous video in which I have taken these encoded text and tokenization, etc. in very detail. So let's go ahead and take here encoded text is equal to token dot text to sequence. All right, now we have here text, and if you see here encoded text, all right, just few lines. Let's go ahead, just take the few 3 list. Now those text which we have earlier in a text format, now it is available in numeric format. All right, perfect. Now let's go ahead and since one more thing you should notice here is that the size of these lists are variable. That's when the size of the list is not fixed, and machine learning algorithm needs fixed size of data as an input. So what we are going to do here, we are going to assign here a fixed size, that we are going to say here max length is equal to 120, and here capital X is equal to paired sequences. Then we need to pass here encoded text, and then max length is equal to max length, and the padding which we are gonna do here, that's the post padding. Let's go ahead and run this, and once again now you can visualize capital X here, which we have here. All right, so this is X. Perfect. Now let's go ahead and see the shape of X, which we have 4000 rows, and the size of each list has become constant, which is 120 the data in each list. All right, now the task is to work with the GloVe vectors. Okay, so you see here how we are gonna work with the GloVe vectors. You need to first understand these GloVe vectors, how it works. You see here we have GloVe vectors inside the glove.twitter.27b, but we are gonna use here 200 dimension vector, this one. So I have taken this outside of this folder. You see here, it is here, the glove twitter 27b. This is .txt format file, and which we need to read. Okay, and one more thing I should show you here is this. There, sorry. Just a second. Sorry, I should remove these actually. Okay, just a second. All right, so here we have here our GloVe vectors. If you open that GloVe vector file, you will see there at the first line there will be always a word for which vector is there, and the first line followed by the 200 vectors. So the U is represented with these vectors. Now you see these are the vectors. All right, so the vector size is here the 200. Now our task is to prepare a dictionary, so that the dictionary should have all these vectors, and the key for that dictionary should be this value, the alphanumeric value, and then the value should be the vector. All right, so we are going to do that here. GloVe vectors is equal to dict. Here we have now the dictionary here. GloVe vectors is equal to dict. Now what I'm going to do here, I'm going to write here time. Okay, and then I'm going to read that. Okay, so that I can read with file is equal to open, and in this now you see I have GloVe vector twitter 27. Okay, so the GloVe twitter, this one. All right, so this is the file which I have here currently, GloVe twitter 27b 200d.txt. so this is the file which I'm going to read here, and then I need to also give here encoding. Encoding of this text file is UTF-8. I'm going to give this, and once we give this, the file pointer will be placed into a file, and then I'm going to read this file line by line. So for line in file, and then I'm going to say there values is equal to line dot split. All right, after that I'm going to say here word is equal to values and then 0. All right, and then here we have vectors is equal to np dot array. All right, so here we have np dot array np dot as array. Actually this is going to happen. So this list will be converted as array, and then the values from the first place to all. So this first, because the 0 is actual the word for which the vector is there, so we are just skipping that word, and after that there is a vector, so that vector is being placed here in the vectors. All right, and that vector I'm gonna place here in the GloVe vectors, in GloVe vectors dictionary. So we have here GloVe vectors, and then here we have word, GloVe vectors dot word is equal to, we have here vectors. All right, and then finally I'm gonna close this file. So file dot close. With this, now you see here what we have got. We have got file dot close. All right, so it might take a little time. It takes around the 2 minutes. So let's go ahead and wait for some time to get it complete. So all right, this vector is loaded into GloVe vectors dictionary. And once this vector is loaded, let's go ahead and see the keys of these GloVe vectors. Okay, so we can get here. The keys are actually the words. This might take a lot of the time. I should not have done this. And also you should not do, otherwise your the notebook might get crashed. So all right, so these are the keys. Let's go ahead and see the length of these keys. Okay, just wait a second. So the length of this GloVe vector keys we can get like this. Okay, so it says that we have around 1.2 million keys. All right, so 1.2, you see here, it's 1.2 million the keys. That's the unique words here are present. All right, now once we have that one, now let's go ahead and see vector for particular word. So we have here GloVe underscore vectors dot get, and let's see if I get here dot u, and shape of this vector is, you see here, the 200. All right, but if I write here some random digits or numbers, you see here it says that it doesn't have, because there is no, okay, so it's none. Actually it's returning none, so there is no vector for this random digit. Okay, but if you type here any word, then definitely you will get some the vector. So this is the global vector. Now what our task is to get the global vector for our Twitter data. Now you see this global vector is for 1.2 million the words, but our Twitter data have only around, I think, the 6,000 words. Okay, 6,793 words. Now what our task is to do? Our task is to get the vector for each of these individual tokens. Okay, like I, to, the, a, is, my, you, etc. So what we are going to do? We are going to look for the keys, or like these keys, into the keys of the global vector, GloVe vectors, and then we will extract the vectors if that key is present into this GloVe vectors. All right, so let's go ahead and write the function for that. So let's say here we have word vector. Okay, word vector matrix. There, first we need to create the np.zeros, and that should be the size of vocabulary. The vocabulary size is more than 6,700, and then the each word should have 200 more dimensions. Okay, so that's the for each word. Now we have word vector matrix. So now what we are going to do here, for word and then index in token dot, now you see the token dot word index will give you the dictionary there. Now we are going to get here the items, that's mean the key and the values together. So what I'm gonna see here, the vector is equal to, okay, so GloVe vectors dot get word. So for this particular word, okay, I mean this is the word index of our data. So for first, which is I, for this particular word, we are going to get the vectors from GloVe vectors. And then we are going to check if this vector is none. Okay, you see there is many words for which global vector might not have the vector. So we need to check if that vector is none. So if vector is not none, okay, then we need to store that vector into word vector matrix, okay, for that particular the index. All right, so here we have a vector. Once it is done, then we are going to check, else we are going to print those words for which this do not have a vector. All right, so let's go ahead and run this. Once you run this, you will see here the most of the words for which global vector do not have vector are misspelled word. Okay, so these are the misspelled word. So it's difficult to get the vectors for these misspelled words. So the one way to handle these words is to correct the spelling, otherwise remove these words. All right, perfect. So this is quite long list. So now what I'm going to do here, now we have reached from where we can build the model. Okay, so we have reached here TF 2.0 and Keras model building. All right, perfect. So the first of all, we have the X data. Now you see this is the X data. All right, the few things you need to notice here is that this word vector matrix, we need this word vector matrix as well as this X data. Okay, so this word vector matrix we are going to feed into our model before compilation, and after compilation, when we are fitting the model, we are going to pass this X vector. All right, so the first of all, we need to call here X train, X underscore test is equal and then Y underscore train and then Y underscore test is equal to train test split, and then here we have X, Y, and then we have here a random state. All right, so we have here random state is equal to 42, and after that we have here the test size. Okay, so we have here test underscore the size is equal to 0.2. all right, and then here we have here stratify, all right, is equal to Y. Perfect. All right, so with this, now we have here what we have currently. We have X train, X test, and then Y train and the Y test. Okay, so we pass this. Once we pass this, now what we are going to do, we have splitted our X and the Y data into X train and the Y train. All right, so now what we are going to do here, vec underscore size is equal to the 200. Okay, now do you remember in the previous video, here, okay, in this video I have covered these things and I had built the model. Okay, so let me show you that model. That model is somewhere here. Yes. All right, so this model I have already built there, so I'm going to just get that model. Okay, so I am going to get that model, and the difference I'll tell you where it is a little different than that. If you see in the previous model, you will see here in the embedding layer we have just vocab size, vector size, and input length as a max length. But in the current one, you see here we have vocab size, vector size, and input length. Okay, so all these were present in the previous video, but the last one, which is really very important, is this one. Okay, the weights. All right, so this is the weights, the weight which we have got here, and the weight is actually the vectors. That is the vectors. So this is the vector, word vector matrix, which we are going to feed in this model. In the previous video, we had told the machine learning model to get the vector automatically. But here we are going to say this model that don't get the vector automatically. I am providing you the vector, and you need to just train my my input data on that vector. So I say here weights is equal to word vector matrix, and it is not trainable. That's when trainable is equal to the false. All right, perfect. And after this, all other lines are exactly the same. I have just added one more line. Optimizer is Adam, learning rate with 0.0001, and the epoch rate as the 30. All right, perfect. So let's go ahead and run this. As previously I told you that you need to pass this X after the compilation of your model. So here I compile this model. Now I am going to pass this X train and the Y train in the train set, and X test and the Y test into the validation set. Let's go ahead and run this and see how much time it is going to take. All right, so it has says that instance with retype argument instance passing to it the constructor. Just wait for a second, it will take a little time. Okay. All right, so it has shown the error. The error, as you know, because this error happened, I have been using my CPU for other I'm using my CPU for other process as well. So let me switch off my GPU, actually not a CPU. If you have a GPU in your computer and your other program is using that GPU, then you will get this type of the error. So let me switch off my GPU, and then we can train it. All right, so I have switched off my GPU, and now let's go ahead and run this model again. It took a little time to switch off my GPU. If you have GPU and if GPU is being used by another process, then you might get this kind of the error. And if you are running this algorithm, I think, let me see again why. I think GPU is still running. Just wait a second. All right, so it took a little time. Sorry for interruption. Let's go ahead now, run this. Now it should start. So they have few warnings that should be ignored, not a problem at all. Now the training has started here. Now you see, and if you see here at the very first time, the training accuracy, validation accuracy was 49%, and then it increased to 56%, and then 59%, and so on. Now it has reached to 68% and 70%. All right, although the training accuracy is just 65%, which says that the model is still underfitted and it can get trained for more number of epochs. Now it seems that we get the accuracy around the 70%, and it can also reach to the 71%, which is definitely better accuracy than the previous model which we had used previously. Previously we had used the word to vectors, term frequency, and inverse document frequency, bag of word, etc. There the maximum accuracy on the 4000 Twitter data, we were getting around 70 or the 65% accuracy, but we have not reached the accuracy of 73%. So with this we have definitely reached this accuracy and broke that barrier, and in the final it has reached the 74% of accuracy, but definitely it has overfitted here. Okay, So with this, the training epochs, you can clearly see that it has helped a lot. The global vector is performing better than the word 2 vector. All right, now in the final step, what we are going to do, in the final step, we are going to apply this into the testing. Okay, so let's go ahead and test this model. So for testing, we need to make a function here, def get underscore encode. All right, and then x. Then x is equal to token dot text to sequences. All right, so we should pass here text. Okay, so we have here text to sequences, and in that we need to pass here x, and then x is equal to pad sequences. This is the same process. You always need to do a same process on the testing set as well. The process which you did in the earlier, okay, in the training time, okay, during the training time. So sequences x, and then here we have max length. So the max length, we have here max length, and the padding, we had the post padding, and then finally we can return here x. The one thing which we are missing here to clean it, so we can say here x is equal to I think it was the get clean. Oh, yeah. So get clean text x. All right, so this is the process. Now let's go ahead, and if we call this the get encode, and if I pass this, hi, how are you? Okay, sorry. So you should get this. Okay, so this is the sequence, and I think I should put it into actually the list. Otherwise it will send you a sequence for each character. Now you see here, so this is the sequence which we have 1, 2, 3 and 4. If I put I, then you will see there a first. Okay, this is the one. So for I, the index 1 is for I. Okay, so this is how it is working. And if I pass something like this, agent, it should pass me like this. Okay, so this is the agent. Now it should pass like is not. Okay, all right. Perfect. After this, now what we are going to do, now we are going to predict our model, which we can do with model dot predict. So predict classes actually, okay, the predict classes, and in that we are going to pass here get encode. So this is the get encoded data, and then I'm going to pass here the x. Let's say if I pass here thank you for watching. All right, so it says that the one, that's the positive sentiment. All right, so in this lesson we have learned how you can use GloVe vectors with deep learning, Keras and TensorFlow 2.0, and how you can achieve a better performance than just a normal TF-IDF bag of words and word to vector representation. Thanks for watching, and please like and subscribe this channel so that you can get updates directly into your inbox whenever I make new videos. Thanks for watching. Bye bye. Have a nice day.